we're done here. We're moving on in our slides here. Dave Bressler and Dave Arscott here. You can certainly be in touch with either of us post-workshop with questions, comments, whatever. So Dave is going to go through an overview of WikiWatershed, and then he's going to go into a general overview of Model My Watershed, and then he's going to put it all in the context of the Delaware River Basin with, he's going to try to get through 3 examples in a couple of different watersheds throughout the basin. So I think that's all I've got as introduction here. If you have questions or have any issues, please just put them in the chat box, and I will respond as we're going along here. And I will pass it over to Dave at this point in time.
All right, thanks for the introduction, David. Hopefully the audio is acceptable to everyone. If there's any glitches, please let us know in the chat box. And please take a moment to respond to the survey. This just helps us know who we have on the line. And then the post-survey, as David mentioned, we'd love it if you could follow up with a quick other couple questions to answer. So a few of you, we're up to about 24 people that have joined on the attendee list, and it'd be great if we had more responses on the Google form to document who might be here. So I should be showing that. You should all see the live results of this short survey coming in. All right, I'm going to go ahead and move through to the presentation side then, and it'd be great if you could continue to access that survey and fill that out for us. So the topic of today's webinar is introducing WikiWatershed, and in a fairly short introduction in order to then work with Model My Watershed web app and get into some of the details of using that tool within the Delaware River watershed. I need to share with you that the Stroud Center is part of a large team to make WikiWatershed possible. Stroud Center, this is an initiative of the Stroud Water Research Center, but it would not be made possible without the folks you see on the screen. In particular, I'd like to acknowledge the web developer that's helped make Model My Watershed web tool a really fantastic tool for everyone to use. And I'd like to thank the partners on the technical team, Anthony Alftenkamp, Barry Evans, David Tarboten, Jeff Horsberg, Scott Haig, Robert Cheatham, and Emilio Mayorga from various organizations that help pull together the technical advice and direction for modeling enhancements. Nanette Markham-Dietrich and Carolyn Stouter, part of our team on the education side that are building curriculum and working with teachers in middle and high school across the country. And then, of course, there are a number of folks here at the Stroud Water Research Center involved in WikiWatershed initiative. We've had significant funding from the William Penn Foundation to enhance features in Model My Watershed and elsewhere for use in the Delaware River Watershed Initiative, and that project is the focus of today's webinar, where we will get down to some details within the Delaware River Watershed and see how Model My Watershed can help inform us about water quality, restoration, and protection goals as part of that initiative. The Stroud Center has also received funding from the National Science Foundation and several other funding entities to help make this all possible, and we thank those organizations for their efforts and contributions. So without further ado, I'd like to dive into WikiWatershed.org and share with you the details of this online web application. And I'm going to move over then to my web browser, and if you'd like to follow along in your own web browser, if you can split the screen or you have two screens in front of you, you're welcome to follow along and use this tool simultaneously as we explore Model My Watershed. So the WikiWatershed.org website is a landing page where the Stroud Center has assembled a number of tools for watershed work and monitoring and managing watersheds. You can explore these tools on your free time or join us back here on December 20th for another webinar where we'll share a little bit more about our Enviro DIY initiative. But for today's webinar, we're going to focus on Model My Watershed. And before I launch the app with this particular button here, I'd like to point you to the other resources that are available for learning more about Model My Watershed and access to the documentation and technical documentation for how the model works. So if you click on Model, you'll jump over to the Model My Watershed information page. There are links here to a help page, which you can also access via the top bar, where we have instructions, videos, curriculum, and the ability to report bugs or feature requests or contact us. When we move through to the help page, we have a number of tabs that we can select from. You'll see the video listing down here. This webinar will appear through this link on the video page. Under documentation, there's a link to a reference document, which I'll come back to later on, but also links to a summary of releases. And when we click on See Major Releases, we are regularly updating Model My Watershed, and so some functionality improvements happen every 6 weeks to 2 months. And when we have major releases, we will describe in here with blogs how the tool has been enhanced or changed, so you can keep track of what's new by accessing the releases. And then finally, under the Events tab, I'd like to point out that you can always go here to find out when we're having other webinars or other events, workshops, etc., focused on our WikiWatershed toolkits. So check here for future webinars. We have 2 more coming up in December that are relevant to our WikiWatershed initiative. Okay, so now back to the model and launching the app. When we launch the app, you will open a new window in your browser, and you're now at app.wikiwatershed.org, and this is a mapping interface, and if you have location enabled on your web browser, the map should zoom into your locale where you're sitting. And you'll see the screen that shows sort of 3 or 4 different components: the large map window, the white bar on the left, which is sort of the project tab, and we'll get started in just a moment. But before we do, I'd like to point out the lower right-hand corner. There's a plus minus for zooming in and out. There's a GPS symbol there to zoom into your location if you're not already there. And then there's a hide sidebar function. If you'd like to maximize your map window, you can do that at any time with that tool. There's a Layers tab that can be compressed or expanded down here that has a bunch of different layers that we will explore in just a moment. But they range from stream information to land use information and changing the base layers to satellite views. And then in the upper right-hand corner, I forgot to mention that when you first log in with, click and join Model My Watershed, you may have a window that pops up and asks you to log in. And logins are free if you don't have one. When you do log in, you will be asked to volunteer to submit some information about who you are. You can forego entering those fields, but we would like this information to help us with our understanding of who is using Model My Watershed and how we can better support your needs. So please fill out the profile information there. And in the future, we'll be adding more features to the My Account page to activate other features or change units from metric to English. At the moment, we only have this in metric. Then final introduction is a search bar up in the right-hand corner. This is where you can search geographically the map in Model My Watershed. And we'll do that in just a moment. But before we do, I'll come back to the Layers tab and click on the Base Map tab and point out that the initial layer here that you're seeing is a street view that happens to come from OpenStreetMap, but you can change between streets or satellite imagery. This layer comes from Esri, or satellite with roads, or a terrain view. I like the terrain view for many of my projects. All right, so let's get started on a project and move towards drawing polygon or delineating an area on my map so that we can begin to explore what the software does. There's many different ways to select an area: by boundary, free draw, or square kilometer. You can delineate a watershed by dropping a point on the map, or you can even upload a file that contains a polygon for your area of interest. This must be a shapefile or a GeoJSON file. And for those that don't know those formats come out of the geographic information systems, and your GIS guru can help you develop those if that's how you'd like to do that. So I'm going to go back to Select by Boundary and click on the USGS Sub-Basin Unit HUC 8 to start. And when we do that, you'll see a red outline across the maps that show you the boundaries of different HUC 8 watersheds that the USGS has delineated in their data layers. And when you hover over the boundaries, you'll get the names of those HUC 8s. You can also then click on any one of those HUC 8s, and when you do, the area will be selected and highlighted, and some information will be gathered from the mapping layers within Model My Watershed. There are a number of mapping layers that we'll go through now. The first map layer is land cover distribution. These data are from the National Land Cover Database, and this database was made available for the time period of 2011. There's documentation here that you can trace back to find those data should you wish to work with them on your own. But you can see there's a little toggle here to turn on and off the land use data layer. You'll also notice that under the Layers tab, National Land Cover Database is also listed there on the coverage grid, and you can turn things on and off here. If you hit the information symbol, you'll see the key, color-coded key that explains the colors on the map, and these colors also link to the bar chart graph that shows you the percent coverage of each category for the area that we've selected. And then finally, you'll see a slider bar that you can toggle to the left and to the right to change the transparency of this land cover grid. And this really helps if you're at all curious about the accuracy of the delineation. You can increase the transparency and turn on a satellite image, and you can begin to explore in detail how the land cover database is describing the satellite image and whether these things line up. So red here should be developed space. There's various categories of developed space, red through pinks, and the browns and the yellows are agricultural lands, both row crop and pasture, and the greens are forest lands. So you can use that tool to help investigate the land cover database. So back over to the left bar here, the top part of this bar right now under land cover is showing a bar chart to summarize our land use, and then there is a table of all of this information for the area as well as the percent coverage. You can sort the table by area or coverage percent, and you can download those data. And when you do that, you can download as a comma separated file, which could be ingested into your spreadsheet like Excel. The next tab here is for soils. These are the hydrologic soil groups from the USDA's GSERGO database, registered in 2016. Again, there's a link here to technical documentation if you're interested in learning more about this data layer. And again, we can turn the soils layer on and off right here at the top of this window. And under coverage grid, we can turn the layer on and off and change the transparency of the data layer. So the data presented here are the hydrologic soil groups, ranging from high infiltration soils to very slow infiltration soils, with some gaps here on the more urbanized soils that aren't categorized within the GSERGO database. So you'll see some gaps in this data layer. So between land use and soils data, we have the bulk of the information needed to begin to model and estimate how water moves through this watershed and how water quality is influenced by all of the land use and the soil types in this watershed. But there are a couple other pieces to the puzzle that we bring in for modeling purposes. There's animals, point sources that I'll get to in just a moment. I guess before I do, I should point out, again, there's a bar chart here for the various soil types and a data table that one could download as a comma-separated value file if you'd like to use these data in an Excel sheet. You can also highlight the text there and copy that to your clipboard, and you could then easily paste these data into Excel, and it should parse those data quite neatly into a proper spreadsheet program. So there are many different ways to access the data that are summarized here, and it hopefully is easy enough for you to do in a variety of ways. When we click on the Animals tab, we have another data layer that isn't projected as a layer, but it is the information is collected by the algorithms here for the animal census data. This comes from the USDA. These are county-level census data, and the animals are projected across this landscape based on the county census data and based on the percentage of agricultural lands you have in the area of interest that you've selected. And you can, again, find more information here under the technical documentation link. When you do click on that link, you go back to wikiwatershed.org webpage, and we are under the Help and Technical Documentation. There's a rather lengthy technical document here that's easily searchable, but also has a nice table of contents that can allow for easy clicking to different source data that are represented in Model My Watershed. So for example, with the animal data, I believe we were down here under additional data layers, and you'll see animals, and a link then can take you to where the USDA has more information about that data set for you to explore. All right, the last piece of information that we'll use in modeling is this point source layer. When we click here, we see a discharge monitoring report that contains annual average values. These data come from the EPA's National Pollution Discharge Elimination System. And if there are discharge points within your watershed, they'll appear in this table. When you hover over them, you can see blue dots appear in your area of interest. And if you click on the link, the map will zoom to that and show you a little bit more information, where it is, what kind of discharge, total nitrogen, and total phosphorus information is attributed to that particular permitted discharge point. And again, you can download those data as CSV or copy-paste them into Excel or a spreadsheet if you like. Within the Delaware River watershed area, we also have all of these permitted discharges in a viewable data layer. We can toggle this on and off up here at the top of the table, or on the Layers tab with the observations down here. We can turn these on and off, and when we do that, we can hover over and click on these orange dots and also get information about these point sources through turning on that data layer. This particular visualization is specific to the Delaware River watershed area and is sort of one of the enhancements for the DRWI community. All right. So those are the primary data layers that are ingested into the models that we'll explore in just a moment. There's one more layer here that is labeled water quality. This tab is specific to the Delaware River Basin only, and here we're projecting or visualizing results from work that Scott Haig and Barry Evans did to create this stream reach assessment tool. And many of you may know about SRAT. If you don't know about it, again, you can find technical details here, and you can get to the Stream Reach Assessment Tool website where the Academy of Natural Sciences has more information posted, or you could contact Scott Haig. In addition to having these summaries here, you can also go into the I believe it's in the gridded area, and scroll down and activate what's called the DRB catchment water quality data, total nitrogen loading rates from SRAT catchments. This is a Polygon layer that shows total nitrogen loading rates from SRAT estimates, or that algorithm, and the shaded colors are reflective of the different loading rates in kilograms per year. So there's that layer. There's a total phosphorus shaded coverage layer, and then there's also a total suspended solids coverage layer, and you'll note these are in shades of gray on the map. Under the Streams tab, there are companion layers that are relevant. Delaware River Basin TSS, concentration from SRAT. And activating this layer highlights the streams line layer on your map and provides a color code to the estimated TSS concentrations in those different stream reaches that are part of the SRAT information. So together, the visualization as well as the data table gives you an idea, without even running a model, what the SRAT process projected for total nitrogen, total phosphorus, total sediment, as well as many other data points for average total nitrogen, average total phosphorus, and TSS. This is by stream segment. There are many different stream segments here. In fact, there are 60 tables of stream segment data here, and you can click through these tables using the little forward and backward arrow. You can click on any stream segment to then find that stream segment and highlight it on your map with the map zooming to that. So this is a way to begin to identify hotspots that have been predicted to have high total suspended solid loading concentrations or total nitrogen or total phosphorus without even running any models within Model My Watershed. All right. By the way, we're down here in the Christina River Basin as the area that I selected. I think I'll use this next step as an opportunity to select a different area that may be a little further up. I'm going to turn off some of the data layers and go back to my terrain view and start again. I'm going to click on the Delaware River Basin High Resolution Stream Network. This is another product that's only available within the Delaware River Basin. This was a high resolution stream network that came out of this terrain analysis using digital elevation model routine that David Tarbow at Utah State has developed. And you'll see as you zoom in and out, the resolution of the streams layer changes with your zoom function. And when you zoom in to high detail, you'll see an amazing number of very small stream reaches appear. It should be noted that these are estimates of stream channels based on a modeling routine, and not all of these stream segments have been field verified for their accuracy and whether or not they actually appear on the landscape. But they should be reflective of small valley features on the land where water is likely to be aggregating and collecting and starting to form the tips of your headwater streams. And of course, in urban areas, many of these may be buried by parking lots or urban infrastructure. So this is a neat tool to help guide you if you're looking for areas where the water is just accumulating and entering into the stream network you're studying. And you'll see a pretty big difference between the high resolution stream network and the continental medium resolution stream network that comes from the USGS NHE Plus data set. So the detail we're providing here is really quite helpful for some exploratory work if you're out in the field looking for streams to monitor or do projects on. All right, so there's another really fun tool that's called Delineate Watershed. And within the Delaware, you can delineate a watershed by clicking near a streamline based on either this medium resolution data set or the Delaware high resolution data set. So I'm going to choose Delineate Watershed using the high resolution tool, and I'm going to turn on the high resolution stream layer, and I'm going to drop a point here, and we'll see what happens. The tool should take the point and move the point down to the bottom of the valley, find that valley, that stream outlet, and then use a digital elevation model that's part of Model My Watershed to delineate the topographically defined watershed area upstream of that point. And indeed, it did that in a matter of a couple seconds, and quickly then also processed the land use, the soils, the animal numbers, queried for any point sources. There were no point sources here, and brings together the SRAT information. All right, so that's another fun tool. I'm going to zoom back out here and select a slightly different area to then run a modeling exercise. And let's find something that has a little urban area as well as maybe some rural area here near Phillipsburg. Click on the map and delineate this watershed area. We have a mixed landscape of developed, forested, and hay pasture. And now I'm going to run a model. We're going to choose the Watershed multi-year model. For those of you that know MapShed, MapShed is a model that Barry Evans and his team at Penn State have developed over several years that we are implementing in Model My Watershed. And this model then queries a precipitation database that is about a 30-year record of daily and weekly precipitation estimates. And hopefully this pushes through the routine. And it takes that precipitation data and pushes it through this area of interest that we've selected to then estimate how that water is partitioned into groundwater, stream flow, and evapotranspiration, and a couple other outputs. Now this one's taking a little longer than I anticipated, so I may start a new project and try this again. Occasionally this will happen for you, in which case you can go back to the Analyze button at the top and try again and see if that helps. Maybe, let's see, I don't have the modeling. That we're all trying to do this at the same time, and I'm going to zoom back out, start again. See if we're testing the limits of the Amazon Web Service. Select a different area, select by boundary, the lower Musconecton. Select the model, run the Watershed multi-year model. And wait just a moment. There we go. All right, so the model, the Watershed multi-year model has run, and there are two data output layers here. There's hydrology and water quality. Let's go through the hydrology tab first. This is average monthly water fluxes from the 30-year precipitation data set. And if you would like to get into the technical aspects of how this model runs, I'll show you where you can source that under the technical document in just a moment. But you'll see a graphical representation of precipitation over monthly, over 1 year. That's the average of the 30-year data set. And if you click the drop down, you can show the prediction for evapotranspiration, surface runoff, subsurface flow. If there are point sources, it would show those contributions. And then the last one is the average monthly stream flow prediction. And all of those data are available in tabular form down below. And you can copy paste those or download those data. So the other tab here is water quality, and this shows the average annual loads from those 30-year daily fluxes. And there are two tables. The first table you see attributes sediment, total nitrogen, and total phosphorus loads to different land uses within this watershed area, or attributed to farm animals, stream bank erosion, subsurface flow, point sources, and septic systems. Scrolling down, you can access the summary data for the total loads that would be estimated coming out of this entire watershed area for sediment, nitrogen, and phosphorus. The loading rates per hectare, the mean annual concentration, and mean low flow concentration. Now, if you're interested in using this modeling run for work in the desktop application that you can download from Penn State website that's called Mapshed, and running the GWLFE model yourself on your desktop, you can export this modeling run with this export GMS function, which would provide you with the file required to ingest into that other desktop application to run Mapshed, and then have access to various further modification features and best management practices in Mapshed. So this is the result of running the model based on land use and soils and those other data layers. There's also then the next step is to consider project activities for restoration or best management practice implementation. And when you click on the link over on the far right-hand pattern, you actually open a new scenario window. And if we want to label this window, we can say test best management practices, and save this with that title, and then begin to implement some conservation practices in this very large landscape. And the best management practices that we currently have available are separated into rural best management practices and urban. There's cover crop, conservation, tillage, nutrient management, etc. And when you hover over each one of these, you get a little bit of information down at the bottom that describes the best management practice. And there's further documentation in the technical document and on Penn State's Mapshed website, where you can find out more details about these parameters, the parameters connected to these. So if you want to implement cover crop on the rural landscape, the agricultural lands in this watershed, you click on cover crop. The tool tells us how many hectares of row crops are currently in this area of interest, and then we can add our area that we wish to modify. And I'll add 100 hectares, that's 3% of the row crops that we hope to implement cover cropping in. And when we add that, the model is rerunning and updating the water quality tab here. Along with cover crop, it's common that we also implement conservation tillage. So I'll add 100 hectares there as my target conservation practices. And so on, we could continue to add different best management practices that we might be proposing to put in this landscape. And rerunning the model and seeing the new updated model output. Now we haven't yet finalized a compare function where we can see this project side by side of the current conditions, but you can access these data here for these BMPs that you've implemented, and then jump back over to current conditions, access the water quality tab, and compare those numbers to the current condition estimates for total loads, loading rates, etc. I'm going to do a little cheating and show you some of the projects that have already completed. If you log in to Model My Watershed and you generate an account, you have the ability to save all of your projects. So you can click on your name or your ID up here and click on My Projects. You'll see that the one we're working on in the lower Musconetcong is already saved. And here I could relaunch the project. I could rename it. I could share it and then make it public and send the link to somebody in an email, and they could view it. I am going to go down to one that we had done as a test case called Broadhead Fly Fisherman's Easement. Honeybrook Ag BMP scenario. This is an area that the Stroud Water Research Center is working on in the Brandywine Christina cluster as part of the DRWI up in Honeybrook. And this shows you the project that I've saved. So everything's already completed here. And here are the current conditions for the Honeybrook area. And if you're interested in the Analyze tab and what the land use looks like, it's a very agriculturally dominated land use area with quite a high percentage of cultivated crops and hay pasture. But also a little bit of the town of Honeybrook, there's some developed spaces there. And we could review the animal population and point sources, etc. When we click back over to model, it shows you the model output from the Watershed multi-year model. We click on details. We can see a little bit of some summary information that it's a 10 square kilometer watershed, and that we've run the Watershed multi-year model. We click on the current conditions tab, and we can, you'll see that I have another scenario that I've already finished that I've called Ag BMP Full Implementation. When I click on that, I bring up the model output from implementing these conservation practices, 275 hectares of cover crops added, conservation tillage, nutrient management on 260 hectares, etc. There are a number of conservation practices that we're estimating with this model run here. All right, so I can make this project public, and I can share it with my colleagues or others to show them the output of the model. I can download and compare and contrast the water quality data. So to make it easy on you all, I did a little bit of this beforehand. I copy and pasted these tables from the Ag BMP full implementation and the current conditions, and I pasted those data into Excel. So I have my sources of, here in this column, sediment, total nitrogen, total phosphorus. These are estimates for the current condition, the Ag BMP implementation, and then I can calculate my own percent reductions for total loads, loading rates, etc. So with this best management scenario, best management practices being implemented, I have reductions of sediment at total 67%, nitrogen 22%, and phosphorus 47%. All right, time slips away very quickly when we start playing with Model My Watershed, so I think I have about 5 minutes left before I'd like to open up for questions. And with those 5 minutes, I'll quickly show you one or two other projects that I already have completed. One, let's open Pennypack College Settlement Site Storm Model. So we haven't run this model yet, but this is the other model that's available within Model My Watershed that we call Site Storm Model. It is based on a well-known model called TR55 that has been developed primarily for rural landscapes, combined with SLAM algorithms, which help us with the urban landscapes in this model. And rather than running a 30-year precipitation historical record, this model takes a 24-hour storm event and pushes it through the area of interest. And we can dial in the amount of rain that we have over 24 hours with this precipitation slider over here on the right. I have it set at 4 centimeters over 24 hours. And then we see the runoff, the rain separated into evapotranspiration, runoff, and infiltration. We have a table that shows us those data. And again, you can download those data there. And then we've also implemented the EPA's STEP-L algorithms for modeling. This is a spreadsheet accounting model for estimating total suspended solid, total nitrogen, total phosphorus loads that would come off of that landscape as well. And those data are presented here. Similarly to the MapShed routine, we can add best management practices. I've already done that. We've added a number of land cover. Well, actually, what I added here was a vegetation infiltration basin. This is a project where if I turn on the satellite with roads and take the national land cover off, we can see this is a residential neighborhood and the stream is flowing towards the top of your screen. If I turn the stream layer on, we should see a blue line appear. And at the base here, we have an infiltration basin or a stormwater feature that was built just a year or two ago at the tip of this headwater stream. So here, by implementing this 1,800 square meter vegetation infiltration basin, we've mimicked what might happen if we can infiltrate that water from that stormwater basin for this polygon. We can look at water quality and runoff. And with the site storm model, we have this compare function, which is quite handy. When we click on that, we can see a comparison of our project with the infiltration basin versus current conditions versus a predominantly forested landscape. And we can access both the hydrology side of this model as well as water quality total suspended loads. So that is probably about all I have time for.
We have a few questions here. The first one is, in the multi-year model, how are these conservation practices applied across the landscape?
So the multi-year model, neither of these models are actually spatially explicit. So for example, in this model I drew, using the site storm model, we draw the polygon on the map to implement the practice. But the model is going to treat this infiltration basin the same regardless of where I put it on the landscape. It's more about the size that I've put on this landscape. For the watershed multi-year model, the implementation of those best management practices is not spatially explicit, but it is explicit for the type of land use that you are addressing. So the row crop or best management practices like cover cropping and conservation tillage are applied to the row crop land use in general across your entire area of interest? I think that gets at your question.
Yeah, so Cleo, if that addresses your question, then maybe just respond or follow up with additional question. In the meantime, we haven't.
Oh, Anthony's asking if he could respond. So Anthony, I believe your microphone is active. Go ahead.
Yeah. So we are thinking very much about how to increase the spatial specificity of various conservation practices, because we've heard loud and clear from our community of end users that that's important. So right now, the Model My Watershed technical development team is working on implementing a feature of the desktop application of MapShed. We're implementing a feature called sub-basin modeling, where the large area gets divided up into smaller basins. This is a common practice in watershed modeling. There are no watershed models that are completely spatially explicit. They all lump together the combination of land use and soil types into what they call hydrological response units, and then do a single calculation over that hydrological response unit. But the way that all watershed models work at kind of developing this extra layer of or level of spatial specificity is to do sub-basin modeling, where they divide up the large area into smaller areas. So we're in the process of implementing that right now. We'll probably roll that out this winter, and then we're going to be enhancing the next big effort, and maybe the next big effort of enhancing Model My Watershed will be to improve the way BMPs are modeled, essentially to add more BMPs, to allow one to customize BMP parameters if you want to tweak it, maybe for your location, and then to be able to give some information about the location of the BMP for the sub-basin model to give that extra specificity. All right. Great.
Thank you, Anthony. Okay, so we've got a couple more questions here. One is with regard to MapShed. Does the GWLF handle reservoir / impoundment routing?
Anthony, you want to field that question?
Sure. The answer is no. It is something that we've thought about doing in the future. It's not done on the desktop application. There are two things, actually. The desktop application of MapShed and what we implement in Model My Watershed doesn't do any routing at all. However, SRAT did some level of routing as on the pre-calculated model results from a whole lot of sub-basin modeling that Barry Evans did 2 years ago in kind of a static way. We, as part of the sub-basin modeling effort, we will be introducing to Model My Watershed some routing capabilities. So one could create a scenario that in a sub-basin you do some level of conservation that improves water quality, and that will be reflected in changes in the mean concentration of the streams downstream. Dave is showing how that routing worked in SRAT. So essentially in the next 3 months, we will be taking the static SRAT that Scott Higg developed, merging it with some of the advanced desktop capabilities of Model My Watershed and creating a dynamic SRAT on the Model My Watershed platform to do some of those things. So back to lakes and reservoirs, that new attenuation will depend on the lakes and reservoirs in kind of a rough way, similar to the way Scott did it.
Thank you, Anthony.
Sure.
Okay, and then we have one last question here, just asking about the model in which the precipitation can be adjusted. Maybe, Dave, if you can just demonstrate that again.
Sure.
Site storm.
You know, the site storm model is most applicable to a smaller area than the watershed multi-year model. So to quickly implement that, I just plopped down a square kilometer polygon, clip this out, and this site storm model is the selection here. And this runs the TR55 and SLAM algorithms that are based on coefficients linked to land use and soil types. And then the water quality side is EPA's STEP L model algorithm. And again, the difference here is it's a 24-hour storm event. You can dial in your own precipitation intensity over that 24 hours. And once you change this precipitation intensity, the model updates and generates new estimates based on that new 24-hour intensity of rainfall.
Okay, so David, if that addresses your question fully, I guess, or if you have additional follow-up to that, just pose it in the Q&A there. We have a couple minutes left here before 1 o'clock if anyone else has questions.
I'd like to take a moment to just show some other neat features that have recently been made available. Nationally, there are 2 layers for visualization that you might find interesting. Mean monthly precipitation. This comes from Prism Climate Group, and we have the documentation linked here. But the mean monthly precipitation is specific to each month, and you'll note that when you activate these, either precipitation or temperature, you have a slider that you can slide for the month you're interested in. So there's February for temperature. This is air temperature. Here's September, and so forth. And you can do the same for precipitation. You can change the month that you're interested in, and then there's also a scale bar that shows the color-coded precipitation millimeters per month. So that's a neat new feature that's available. Also, we didn't really show this other data layer that's specific to the Delaware River watershed area, but in the Layers tab that's called Observations, we have, if you click on USGS National Water Information System, you'll see all these dots appear. You can click on a dot, and you can see the real-time USGS data coming in from this particular river gauge. You can see the discharge and the river stage height. And if you'd like to see the historical data, when you click on that, you get a graphical view and some ability to go back in time and look at the record for discharge, river stage height. And if that station had other sensors like water quality, you could click through those as well. So that's a neat feature available only in the Delaware River watershed area. I've mentioned the EPA point sources. There's NOAA tides and currents points as well that you can click on and get some information. Here's conductivity, oxygen, pH, turbidity, and water temp from that station. And then there's Delaware Environmental Observing System sites here where there's more real-time data that are posted. So was there another question or two that came in?
Doesn't look like it.
Oh, can we upload shapefiles? Yeah, this one's really cool. Watch how quickly this goes. I have this pre-canned as well. Here's an upload file, and when you do that, you could drag and drop your shapefile, project file, or zip file right into this box. It must be a shapefile or a GeoJSON, and only the first feature is used, so you can only do a single polygon at a time. I'm going to select a file that I have on my desktop that's a zip file of the Brandywine-Christina River Basin, and when I double-click it, it ingests that polygon and very rapidly clips out that area and summarizes land use, soils, animals, etc. So that's a nice way to make your delineation repeatable if you also have a GIS system and you're using those sorts of files. You cannot yet export your Polygon. That feature may be somewhere down the road. We have other priorities at the moment.
Okay, one last thing, the surveys. I just posted in the chat the post-webinar survey. If folks could complete that, it would be appreciated. Also, if you didn't get to complete the pre-webinar survey, please do that. I just reposted that link as well. So if you're signing off and want to complete that, just copy that link out and just complete it on your own time. But we would appreciate to hear back from you. There's only a couple questions in each, so it should only take a minute or two to complete.
Are you sure that was the pre or post? That was the pre.
I sent the post is one before that.
Yeah.
So there's the post and the pre in there.
All right.
So,
we appreciate you taking the time to join us, and feel free to contact us with other questions. We look forward to sharing more as new features become available, so check back.
Thanks, everyone.
That'll conclude today's webinar. Thanks for joining.
Thank you, everyone.
That was kind of abrupt, but we said we'd keep it to an hour, and we did.